Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ziad Al-Fatafi, and I'm from Department of Electrical Engineering, Universitas Muhammadiyah, Jakarta. And today, I'm going to present electrical load for setting on 500 per 100 kilovolt substation based on historical daily records using multivariate LSTM network. Outlines. In this presentation, I'm going to mention 5 points. The first is introduction. The second is previous works. The third one is methodology. The fourth one is result and discussion. And the last thing is the conclusion. And now I must start with introduction. A report by electricity company in Indonesia estimates that electricity consumption will increase on average 8.42% per year, with more than 79 million people having electricity in 2020. This study also revealed that electricity consumption will increase, like it has increased almost double between 2014 and 2018. And the growth in the electricity consumption must also increase the availability of electricity distribution to reduce the cost caused by blackouts. To reduce uncontrolled blackouts, some countries have developed power generation sites, such as the distribution system and electric energy transmission system that interconnected in the smart grid. What's smart grid? Smart grid is a technology developing with data monitoring system that records a daily electric load conditions. A smart grid concept with the production system provides accurate information as an early warning in the process of generation and distribution of electrical energy. Also, in the data in the smart grid system can be acquired centrally. However, the production system faces a lack of accuracy due to the incomplete records and low data quality. And now I'm going to mention machine learning. Machine learning ML model is developed based on multivariate long short-term memory, which is MV-LSTM, to extract long short-term patterns inside an electric load dataset. This dataset is recorded from daily measurement for 6 months at Shawang Baru Substation, Indonesia. The BOSS model adopts in the basic concept of multi-layer perceptron to record temporal patterns in the several stages, thereby producing more accurate results. This model uses supervised learning techniques to propagate sequential data that target, which is the next event of data series. However, the proposed architecture supports multivariate feature extraction, as in the capture important correlation between multi-dimensional feature. And the last thing in here, this study also basic universal LSTM. It's called UF-LSTM model and naive ML model, including linear regression, random forest, and support factor regression. The previous work. Some studies predict that the sequences using collected data and simplify the process and better record temporal patterns by using classifying techniques. The data is recognized into smaller dimensions. The clustering method is predictably useful for large solve predictive model applied at the expenses of resolution. By using linear regression analysis, researchers can make persisting models with a limited number of clusters. Some research uses a Proton model to analyze single explicitly with a high production of outliers. However, the concept is only implemented on the small one dimension listed with the involving long short same data equations. LSTM improves the performance of time series data prediction system. The temporal pattern codes as a strong version of data between this current measurement and the previous measurement. Using LSTM, this temporal change can be extracted previously. Previous study have discussed the ability of LSTM model to predict expenses data. There are potential for this learning model to be used as analyze the temporal relationship between long-term measurements of multivariate variables. Research methodology. A data measurement was recorded at PT PLN, the electricity company in Indonesia, in Cawang Baru, East Jakarta City, the special region of Jakarta. From this record, several data were obtained, including data on daily active loads, relative loads, and load current on a 500 per 150 kilovolt power transformer unit for 6 months from April to September in 2020. The data that has been obtained will be used to observe conditions of electrical load connected to the power transformer and first electric load 1 day ahead. Linear regression. What's linear regression? The shortcut is LR. It requires a linear relationship between independent variable and the dependent variable. The linear regression method can select the relationship because it's used a linear transformation approach to predict the propagations. In simple terms, the purpose of the LR method is to predict the value of y by knowing the value of x and finding the values of m and b with the best error. Mathematically, the equation of LR is determined in equation 1 because in this reduction model, this error should be obtained to the equation as we can see here in the figure. Second of all, random forest. Random forest is a supervised learning algorithm released in the early of 20s. Random forests are commonly used to solve problems related to classification, regression, so on, so on. There are two things that make this algorithm called random. The first thing is each tree grows on different bootstrap symbol taken from the training data random. And the second thing is in each spelled node during decision tree formation, a simple routine of m variable is selected from the original data set, and then the best one will be used in that node. In this algorithm is combination of several tree predictions, predicators, or can be called decision tree, where each tree depends on the random vector value, which is simplified fairly and evenly on all trees in the forest. And now I might talk about support vector regression. The shortcut is SVR. Both classification and regression facts can be solved using support vector machine. This study focused on SVM for regression tasks. Known as support vector regression, the model produced by CVR relies on only upset in the training data, as the cost function discretes simplifies whose prediction is close to the target. A linear CVR works by making a straight line in one class. Sieving is a way of dividing a data set into two types of data sets by using hyperparameter. Furthermore, if the goal of this thing is to divide the data set into classes, then the SVR and the opposite, how to get the data set into one class by keeping minimizing the evaluation value. There can be an infinite number of hyperlanes to choose from. But the option one can be achieved using latent optimizing producers. Long short-term memory LSTM. Multivariate data analysis and research that started with the application of new computational techniques that allow analysis of more than one dimension. LSTM network supports a multi-channel input. This means several features and sequential data can be processed simultaneously usually and will affect the propagation of inputs to output. Multivariate data has several features with positionally variable temporal patterns for generating knowledge convergence in LSTM networks. Therefore, it's important to record multivariate data and periodically to produce better performance than unvariated data. In these figures, we have, in the left figures, we're talking about linear regression. As we separate the testing and the training, as we can see, it's almost the same. It's kind of failed, but in the left table, it's used linear regression as well, but it shows the RF. It shows the RF. As we can see, the testing and the training is a bit more, and in the below table is talk about the resulting of using support vector regression SVR. And in here, in the left table, we're using unvariated LSTM. After we separate the training and testing, we can say that the predicted power has improved more by more. And in the right table, it's the resulting using multivariate LSTM. It showed that MV-LSTM model and result and discussion. We can see here in training and testing, the highest result for training is 0.9936 in multivariate LSTM, and in testing, the maximum value was 0.33688. And for training, the RF, the highest number was 1.7533, but in testing, the highest value was 3.5829. In conclusion, I might just say what I said before, but in different ways, and explain more a bit. Machine learning models for daily load presetting using a real-world data obtained from measurements at Chowang Lama Substation in Indonesia. Temporal horizon characteristics were recording using temporal feature extraction on the multivariate data, including system voltage, frequency, current, active power, and reactive power. The proposed ML model combines a daily measurement from 3 weeks behind, multivariate LSTM, and deep learning. The output of the production model is load consumption, active power the next day. A performance matrix consisting of MAE, RMSE, and R the power of 2 was used to evaluate the progress of MV-LSTM along with the 4 ML methods from the lecture, including UV-LSTM, LR, RF, SVR. The results show that the processed MV-LSTM is the most reliable and robust in stating future active power with the R of the power of 2, source of 0.9936 in a training data subset. In this point, the proposed MV-LSTM network has superior in producing better prediction performance than in the and MV-LSTM, CVR, CVR, SVR, LR, and RF in testing data subset with the power of R, R to the power of 2, source of 0.3688 and 0.3645, also 0.1332, also 0.1438, and the last thing is 0.1234, respectively. In addition, and the last thing that I'm going to talk is there are promising studies on a finding of the multivariate patterns to improve performance, especially in the testing stage. And I hope our research is going to work. That was the last thing that I have mentioned today. And thank you for listening to me. Wassalamu alaikum wa rahmatullahi wa barakatuh.